Start recording right now. Okay, so today's lecture will be kind of short. I had some other things to do, so I didn't have too much time to do everything I wanted. So we'll first go over classes. I didn't really have time to actually create my own notes, so this is not mine, but I will leave a link to it as well. So essentially, classes are very important or useful, and essentially you need to know what classes are to understand what exactly pandas is and what a data frame is. So I guess we can just start, like, what is a class? So here they have their own definition. A class is a structure in Python that can be used as a blueprint to create objects that have prototype features, attributes that are variables, and methods which are functions that can be applied to the object that is created, or rather an instance of that class. So essentially, once you see how an object works, you'll kind of get an idea of what it is. But until that, I guess you can think an object is kind of a family of objects that are related to each other. So, like, you have variables, like, let's say, I don't know, you're describing a person, right? Like, you want to know what their name is, maybe what their height is, their weight, like, etc. So essentially, you can have a class, like, let's say, you want to find out, like, let's say Luis, like, dot weight, and like you can find out my weight, or Luis dot height, and you can know what my height is. So all those things are, let's say, related to me. So that's what classes are for. So that's kind of the first thing to know. So it's kind of like an object of objects, but what's cool is you can do stuff within that with that family of data as well, and that's where the methods come in. Methods are just basically functions inside the object. So this is just a very clunky way of defining class. The only thing you really need to know is, okay, class, you just call it kind of like, so it's kind of the same format as the definition. So class, then the name, and then object. So essentially the object will be the same over every time. Since you're just kind of, it's just kind of the standard, just find object, so you're just creating object, and then you create definitions. So basically, the first one, diff, and then init. This is just your standard your standard function that you put inside the object, and this one here has all your attributes. As you see here, like self.name. So that's one attribute. Like let's say in this client, so like in some company, they work with their clients, like self.name, so this is the name, and then like self.balance, and then it's balance plus behind it. So it's like maybe some bank account where they're promoting, like if you join the bank, we'll give you $100. So whatever their previous balance was at their other bank now, and then you add $100 to that, and then like you can add your own what's called if statements. So like let's say if self.balance is less than 5,000, so you get a basic bank account. If it's less than 15,000, you get intermediate, and it's more than that, you get an advanced. So this is still an attribute, but only like we actually use now. Like let's say we call the balance data, and now okay, so with this we're going to create a new attribute. So like immediately, all you have to do is give the person's name and its balance, and their balance, sorry, and then you can create that. And now you're wondering, what's this self? So essentially, I want to get a little bit into the difference between a class and an instance. So a class is just basically how you create instances, and essentially with instances, it's a particular version of a class. So like let's say you create a function that adds two numbers, right? So let's say the function is x plus y. So I probably should write this out. So I'm just going to simplify it. So I'm trying to differentiate between a class and an instance with a function. Okay, so let's say def add, then x comma y, then let's say value equals x plus y, and then return value. Okay. So we all agree this is a function, right? So this would be a class. Like if you think one higher level up, like right here, this is a class. Now what an instance is, okay, so let's say I call this function class add 1 1, right? So and then I can call, like I'll assign this to a variable. So let's say I don't know, new value. Okay, so that's 2. So like if this were, if so now when we have a definition, this is like kind of just the overall layout, and this is like the actual number you get when you do that function, right? But if a class is kind of like a higher level up. So essentially, once we create our class, we're gonna wanna have, like, let's say you have different clients, right? Let's say there's me, then there's another person, let's say, I don't know, Jane. So basically, Jane will probably have a similar thing. Like she'll have a name, she'll have a balance, and then she'll have a level. And then like with another person, so you see there's that same structure. So it's the same thing. So with definitions, since the only thing you're gonna return are variables, you just assign it to a variable like this, and that's it. But with classes, they're a little bit higher level, so people kind of get sometimes have a hard time differentiating between a class and an instance of the class. Basically, once you assign a class to a particular person or object, then you'll understand that. So right here, creating an instance for a class. So you see here, John Doe equals time.
Hi, Luis.
Yes.
I have a question. So we haven't defined any attribute called level. So in the def init portion, so is it just the input arguments, not the I think other temporary arguments or the output arguments? We don't have to define it inside this def init part, right?
What level? No, since level is based off the other inputs.
Yeah. That was I was asking that it's not input argument, so we don't have to define it in the def init part, right?
No, since essentially, if you see here, you assign a level based off the balance.
Okay.
So see here, like if self dot balance. So once you input the balance, okay, so balance is assigned right here. Then the object itself will determine what the level will be. So the only thing you need to worry about are these right here. So if you see in this case, John Doe equals client John Doe 500, and then Jane Defoe equals client Jane Defoe 1500. Now, if you notice, self is just kind of calling itself the actual class. So this is just kind of a way of, remember how I told you in functions you don't have to be specific. So that's the same thing as self. So this is just kind of saying, okay, this same what's it called, the same object, and then like dot name dot balance. If it's kind of weird, I understand. Once you start doing classes, it'll kind of make more sense, and you can play around with this code later on, and then hopefully it'll make a little more sense. And once you start using pandas, all this will be very clear. I honestly learned pandas before I learned classes, which kind of was a mistake. But now that I learned classes, it was very easy because I kind of used classes without knowing what they were. So yeah, it's pretty interesting. However, I think it's better that you guys know what a class is to kind of understand what really is going on with pandas. So then, in this case, we just created 2 new instances. So we have John Joe equals client John Joe 500. So John Doe has $100, and Jane Defoe has what's that? $150,000. So now we can print these out. So if you notice how easy this is, like okay, John Doe, what do I want to know? His name, dot name, and now you know his name.
By the way, Luis, I just realized something. Are you recording right now?
Yes. Thank you for reminding me, since if not, that would have been bad.
Okay.
Thank you.
Sorry. Carry on.
And then print Jane Defoe dot level. So basically, okay, I want to know what Jane Defoe's level is. If she has a premium account, a cheap account, you can just know by just dot level. Then Jane Defoe dot balance, like you can know what her balance is. So that's what's really nice about classes. Like maybe if you could before, you would probably do something like, instead of creating a class, you would just do like, oh, Jane dash Defoe dash level, then Jane dash Defoe dash balance. But you can see how that can get old really quickly, right? So instead of doing that, you can just do this. You see here, so print John Doe.name, and now we know his name is John Doe, and he is at advanced. Oh, Jane Defoe. Okay. Jane Defoe's level, so obviously her level is advanced, and she has $1,100 since obviously this bank adds $100 to your account for joining. So you see how simple that is compared to like creating a bunch of variables for each it's called attribute a person has. And then you can also add, remove, or modify attributes as we like. So in this case, johndoe.email equals jdoe23@gmail.com, and then we can change that again to like, okay, John Doe's emails actually is this. So pretty straightforward. And these are just kind of other functions. You can use get adder. Then this is basically like it says to access the attribute of the object, and then set adder is to set an attribute if it does not exist. So like, okay, so if you want to add stuff to the function, you can do that. However, I wouldn't really recommend that, since you should be creating stuff in a class to begin with, and that's just because of uniformity. So like, you want to make sure all those stuff is in every single instance you create of that class. So honestly, there.
This, can you get over the get into the since 6 and 7? I didn't understand so what are we doing exactly here? So we didn't define email earlier. So can we just define it outside class like this?
Yeah. So you can define it from the outside as well. So that's what you're trying to show here. Like you can define it, and you can even like modify it as well. So
is the del deleting this, or what is?
yes, you're deleting that attribute from the instance, not the class, but from the instance.
Okay.
Yeah. So this is like, you can do this, but and it's kind of confusing. I mean, honestly, I wouldn't do this, since again, like, you don't want to really. This is just in general in code. You don't really want to hard code stuff for one particular. Like, okay, I'm gonna just add this to. If you need to add an email, don't do it this way. Create an attribute in the class, and then you can just. So I mean, they're just telling you can, but again, I wouldn't really recommend this, since there's like, I think the beauty of code is to create uniformity. So. And like, I'll show you later on when we start getting more into coding, like actual like long lines of code. Like, your goal is to have like 1 or 2 cells, like if you're using Jupyter Notebook, that have like the actual like variables you're gonna work with, and everything else would just be calling functions. You don't want to really hard code anything. Like if you need like okay, this is gonna be the name of the site, you're gonna add that. You're gonna assign that to the name of the site, and the rest of the code will just use that variable. You don't want to be too specific in code, because then if you need to modify it, then you have to like modify it all throughout the code. Versus if you just assign variables, you only have to do it once. So it's just telling you can. However, it's one of those things that just lets you, but you shouldn't really do just for. You have to just keep your code clean and efficient, I guess.
Okay.
Yeah, no problem. And then there's class attributes versus normal attributes. So class attributes are just things that go for all instances. So like let's say here client.bank. So essentially like client.bank, it's TD. So this is like some imaginary bank, the name of it, and then the client.location is Toronto. So we're just assuming like let's say we're creating a code for this bank in Toronto, so we can probably just assume the what's it called, this like since this is like the bank. Let me rephrase this a bit better. So like okay, so let's say you're some programmer at this bank, and you're creating a class for all your customers at the bank. So obviously the one thing everybody will have in common is that they're using this bank. If not, they wouldn't be in this database. So like one thing you can always assume that their bank is this bank, and this bank's location is in Toronto. So that's the only thing it's saying. So like I think another example that's probably clear, like let's say you're working with data from like a water district, right? It doesn't matter if you're working with like let's say I don't know, Los Angeles or New York or Chicago's water districts. One thing you probably we can all agree on is that let's say for power, what would be the unit of measurement? Kilowatts, right? We don't really measure stuff in watts or in I guess maybe megawatts, but like most of the time we just use kilowatts, right? Just kind of like the de facto. So like let's say if somebody wants to know, wait, what's the unit of measurement for power? You can probably just create a class instance, and that could be kilowatts, since it doesn't matter if it's like Chicago's data or Los Angeles water district. It will be it should be uniform throughout. So I mean this is one of those things you can do. It's not too common, but it's also this actually can be useful sometimes. And you see here client.bank. Now we know it's TD, and then like so in this case, since it is a class attribute, even if you just print the client, like the actual class, it will tell you what it is, since we hard coded that into the class. And then client.location equals Toronto, Ontario. So in this case, actually I should add that here. And we should be able to Toronto, Ontario. So yeah, that's one simple way of doing that. And then now we get into the fun part, which are methods. Methods are very, very, very useful, and essentially this is how you will do everything in Pandas. So essentially right here we have the attributes right here. Like let's say I want to deposit some money, right, to this account. So you create a new definition inside that same class. So definition deposit self. So again, remember how we like essentially we're calling the same class. So like if you want to know the balance, the level, we're calling it by its own class. And I really wish I could explain this better, but one of those things, hopefully by looking at it you can kind of understand, and not just kind of look at it again and again until you kind of get it. At first when I looked at this, I didn't even know what was going on, so it's just one of those things you have to kind of look at it like a couple of times to really get it. So anyway, so self and then amount. So essentially this will just, again, like we say self, but when we actually do the deposit, the only thing we need to do is the amount. And then this is just so self.balance plus or equals the amount. So essentially you're getting the amount we have from the balance and we're adding it back, and then we're returning self.balance. So essentially, like, let's say we have $1,000 here, then we call this function, right? So like, okay, so we know this is $1,000, and then let's say we're gonna add $100, so we have $1,100, right? So it does that. Okay, so we get so we have 100 plus equal, so that's like 1,000 plus 100 equals 1,100, and then we return self.balance. And when you do return self.balance, it will update the attribute. Hopefully that kind of makes sense. Okay, so
Luis,
yes.
so I have one question. So whenever we're defining any function in within that class, do we have to always keep self as an input argument?
Yes. Basically, for most of the time, you need a self just as since like at least, well, since like in this case we're calling the balance, since we're gonna do some modification on the balance or some attribute, then you're gonna need self. I guess if you're not really using an attribute, maybe you can get away with it, but there's and I believe there's an example of that below. But most of the time, since we're using these methods, our goal is to modify some attributes. So in those cases, yes, you always have to put self in the beginning. And so, okay, so and like,
is runtime error? I mean, some built-in function from Python.
yes. So you can also do raise is just like a built-in Python function. So like, let's say if you like, in this case, you want to withdraw. Like, let's say you have in your bank account you have $1,000. Well, let's say you want to withdraw, I don't know, 5,000. Obviously, the ATM wouldn't just spit you out $5,000. So like, okay, create an error. So basically, raise and then runtime error. So it's just letting the code know, like, okay, this person did a mistake. So yeah, it's just one of those built-in functions. I didn't really talk about it, but yeah, it's just like, yeah, there's so many built-in functions in Python, I probably skipped over it, but yeah, that's what it's for. And then what's it called? So obviously, if you have less, I mean, if you're trying to withdraw more than you actually have in your bank account, they'll raise that runtime error. And if not, then it will just subtract. Like, let's say if you have $1,000 and you want to, I don't know, withdraw 500, then in that case, it'll do that for you. So we see here, Jane Defoe equals client. So the reason I redefined it is we created a new class. I mean, we redefined this class, so I redefined the instance because previously we had if I were just to do this, it's gonna go on based on the instance of the previous class. I mean, the instance will be created based off of this class and not this class. So that's why I have to do that. So I'm going to redefine it right here. I'm going to print out Jane Defoe's balance, which should be 1,500. No, 150,000. And then I'll deposit another $150,000 more. Oh yeah, sorry. So as you see here, I printed out. So I just redefined the client. I called her balance, which is 150,000, and then Jane Defoe the deposit. So you see how easy that is. Okay, if I want to deposit some money, 15,000, and now we have $300,000. So it just automatically updated that attribute for us. Okay, so just as a side note, and hopefully I think you noticed, what's different when have you noticed the difference between calling an attribute and calling a function? I mean, yeah, a method, sorry. Okay, so I think I'll make it a little bit clearer. Like, let's say, so essentially, let's say if you want to get Jane Dill's, oh, actually I have it right here. balance, right? Do you notice? I mean, obviously it's in the print parentheses, but you notice how just Jane dot default dot balance. But when you do dot deposit, you have these parentheses right here. You can't just do Jane dot default dot deposit 1500. It will crash. So essentially, since all what's it called? All methods have some type of input, and it's a function, so you always have to put in those inputs. Now you might be wondering, what if there's some methods that don't have any inputs? We won't really see this in this example, but in Pandas you will. So like, let's say you want to do dot deposit, and like, let's just theoretically say there's no input for this, right? You just do dot deposit like this. You can't do it like this because it will create an error. And this might be a little bit weird right now, but it'll be a lot clearer right now when we get into Pandas. And then I think this is kind of a question I was kind of asking. I kind of don't like this definition, but this is kind of what we have right now. So what is self? So essentially you're just withdrawing self amount. The self refers to the instance upon which we are applying the instruction of the method. So that's kind of what their explanation is. Once next week when I have a little more time, I'll rewrite this into my to my own liking. I'm choosing somebody else's, so I apologize for the okay definitions. I would prefer something a little bit clearer. And now there's two different ways of calling methods, and just so one of them is on.deposit 500, and then you can do client.withdraw Jane Defoe. So basically you're going to that client, you're calling the instance, and you can do 5000. You can do it that way as well. However, I'll probably say you'll never use that ever. So just try using this, because realistically when you're working with objects, this is the way you're going to do it. This is just telling you can do it, but again, you'll never use this, and I've never actually used it before until using like some of these tutorials, but honestly this is not really useful. And now static methods. So I believe this is kind of going back to Yahid's question. So do we always have to put self? So in this case, we can even define a static method. So like, let's say you want to do something that doesn't require the attributes, like right here. Static method, like right here, or that belong to a class but do not have access to self and hence do not require an instance of the function, will work at the class level as well as an instance level. However, the only like caveat of that is you just have to put at static method before. So like in this case, like let's say client.classObject, and then definition make money sound print cha-ching. So we're just printing something out. So you don't really need any of the attributes, right? So you don't need that self. So I think, does that kind of answer your question a little bit more?
Yeah.
So basically you only need self inside the function if you're going to use one of the attributes. Basically the attributes are just kind of the variables inside of the function, and more specifically the ones in the init. So in this case we don't. So shift enter, and then dot make money sound. But do you still notice how even though there are no inputs technically, you still need to use a parentheses since it's still a function you're doing inside. So it's like basically what a method is a function inside the class. So and like when you call any function, you need parentheses. So that's kind of the reason why. Versus like if you were just to do like what's it called, like let's say Jane Doe's balance, you can just take out those parentheses. And then in here we have class methods, which is kind of similar. However, in this case, So yeah, so in this case, when you have stuff like the let's continue these real quickly. Alright, let me blink that for a second. Okay, so when you're using class attributes, so you can use this method. So like you notice how they did cls.bank and cls.location, but you can do that since it's a class attribute. If it's just like a regular attribute like this, then you would need to do that self thing. But here, since it's a class attribute, you do CLS. That's all it's kind of saying. And then we have inheritance, which is essentially, let's say you have a class and you want to add another thing to that class, like I don't know, like a new definition or something. So let's say you want to create a new class, and you can just inherit, like, sorry. So like let's say we have client right here. Now you want to add savings, right? Instead of writing all that code again, you can just say, okay, class savings client, and then just update what you want to do, and then you can. Yeah, so that's kind of the only thing to understand from inheritance. So instead of rewriting classes, you can actually input, like instead of just saying object, like on the other one we said, which basically just kind of a way of saying, you know, just empty class, you can actually say, okay, yeah, in this class put in the previous class, and then just add these two things. So basically, you can do that as well. I honestly have never really used inheritance. I don't find it too useful for the stuff I've done, but inheritance actually is a very important concept in coding, and it's actually very useful for other purposes, but for what I've done, I've never really used it. But that's kind of the basis for classes. Now, if you're wondering why I went over this before I even went over pandas, let me tell you why. So basically with pandas, the only thing you're going to ever really work with is a data frame. Everything else is just manipulating the data frame. Now you may be wondering, what is pandas? You remember I told you the importance of functions, since also these libraries are functions? What I kind of left out during that lecture is, okay, that's true, but pandas itself is a class. So essentially all the data is stored inside a class. And we have these parameters, so essentially we have the actual data, the index, the columns, the data types, and the copy. So these are kind of the attributes that you see right here to that data frame. So now we get into the new lecture, which is pandas. I believe I can, it's kind of short, so I believe we can do it in 10 minutes. So I'm going to do an unorthodox approach to this. Most introduction to pandas will do this, like literally have you hard code, create a new data frame by hand. I don't find that useful. I'm going to do it this way. So right now I'll explain more about importing libraries later. The only thing you need to know now is pd.readExcel. So this is your typical XLSX, so your Excel file. And so all I'm saying here is get that Excel file and put it inside the data frame. And just to get you an idea, pd.readExcel creates that class, and I'm assigning, an instance. So basically, .readExcel and pd, that's kind of a class, and then the $xx is the data, which will create this instance. So all these are instances. So when you look at pandas code, it'll always use df as the default instance. However, this can be anything. You can call it, I don't know, data, let's say project, or you can name it whatever you want. But if you're just working with just one data frame, although you'll work with a lot more, I just use my default one as the F, mostly because I'm kind of lazy and just like working with 2 letters. But yeah, that's all this means. Like, this is just an instance. So I'm going to, so it's just going in, and I'll import this data frame. Okay, it's ready. Now, the moment of truth. Df and I think most of you have seen this before. Now, I kind of want to explain what data frames and what pandas is for. At least I believe most of you come from a Excel background, kind of like what I did. So at first, this might not be very useful to you. Like you can't even scroll through all of the columns, and you really can't do that in pandas. I believe there might be a method, but essentially that's not the point of it. If you just want to look at the data real quickly, yeah, just look at it through its spreadsheet. But that goal for pandas is to manipulate the data, like easily changing stuff and sorting it around. That's kind of the goal of pandas. So this is just your typical data frame, and notice how it starts from 0. It'll skip it and just 3,556, 3,557, 559. So just kind of giving you a quick summary of how this is. I mean, of what you're looking at this data. So like the beginning and the end, and you can later on see like how you can access different parts of this data. But this is just kind of the general overall. Okay, this is this quick summary of the data frame. Now, so as you see here, we have different columns, and going back here, so when in the columns, it's the main way of interfacing with the data frame. We'll be calling its columns. What I mean by this is, if you notice here how everything's in a nice column format. I purposely didn't choose right now kind of time data with water districts yet. The only reason why, since this is very easy data to work with, and this is kind of how all data in pandas in the end should look like. So later on with the more complex data, I'm going to manipulate it, but what I want you to get the idea right now is that the goal for pandas is to have all data look like this. Like every data, not type, every different variable of data should have its own column. You can technically work with rows, and you will. However, in the end, your goal is just to work with columns, since that's just so much easier. And at first, like for me, who came back from an Excel background, you're just kind of used to rows or columns. They're just kind of the same thing, either or. But I think one of the goals with Pandas is to keep all the data neat. And at first it will be annoying, since you're gonna like, why can't they just put stuff there? But it's just forcing you to be neat and have everything easily accessible. And you'll understand later on when we start working more with the data why they have this approach. So we have these columns, right? So the most important thing is like, so actually before that, so df.columns, and you notice there are no parentheses. So this is just an attribute. And index right here, and then you see how it has age, work class, capital gain, education, marital status. It'll tell you all of your columns, and it's actually very useful, since if you look at it this way, age actually might have a space, and when you call the function, so when you call the column, sorry, and you don't notice that space, then you're going to get an error like, why isn't it calling this column? Because, oh, there's a space here. So it's kind of important to also look at your columns. Like, if you create your data, it shouldn't be a problem, but sometimes when you import it, they sometimes leave spaces and stuff like that out, so you have to clean that data. So that's just a heads up. Always check your columns first to make sure that it is in this correct format, where you just want age, work class, capital gain. And so, okay, so let's say I just want to call one column. Here are two ways of doing this. dfh, like in this here with the braces, and then you put the literal name of the what's it called? The literal name of the column. Or I can just do it this way, df.age. Because if you notice, all these columns are also just attributes of that class. But I'll warn you, if you're working with data, you should ideally have it where if there's a space, it should be an underscore. So first of all, just let me do this. df.age, and now we have this long column from 0 to 32,560. So this is just one long column of data. So which is very nice, since in the end, like, okay, so let's say you want to apply everybody's age. you put this into a plotting program. Okay, so what is your what is your y? df.h. It'll just plot everything for you. So that's very easy, and that's why you want everything in long columns, since that makes plotting a lot easier. But you can do this as well, and this will be a lot easier since it's just dot dot dot, and you'll be amazed at how you won't see this in this lecture, but how dot age start calling like different things, so it can end up being like 4 or 5 different dots, since basically you're gonna call one attribute in another method and then call another attribute in that method. It gets really crazy real quickly, but right now this is just simplistic, a simplistic view. But here's the caveat I was saying, like, and this is a good example. df.capital gain. There's an error. Alright. But if you notice here, data frame object has no attribute capital. Wait, isn't it capital gain? But you notice this dash here, pandas won't read that. So basically, if this would have been an underscore, yes. But if you notice how this is a minus, so it's just reading a minus. But also, if you have a space like this, like let's say you name the capital gain with a space, it won't work. But if you do this, df, and then you do capital dash gain, like this, it works. So that's just a side note. This is a lot easier to use, but everything has to just be one word, and you can't have stuff like this. It has to be either one word or words with underscores. If you have spaces or dashes like this, it won't work. So that's just a quick heads up. Now rows. So rows I'll get through very quickly since I really don't care for rows. So basically one way you can do this is df.ilog0, and it'll just give you a row. So basically age 39, work class, state government, capital gains 57,000. Realistically, it will never really work with this, honestly. I mean, I'll probably give one more or two more examples of rows in a couple of lectures, but yeah, this is kind of what you need to know for rows right now. And this is super, super, super important. You probably a good 25% of your errors when working with pandas will be based on this. Data types. So essentially, this is kind of the ups and downs of using Python. Since like we covered it like I believe 2 lectures ago, Python is an interpreter and it just kind of guesses what the data type will be. Pandas is the same. Like let's say age is like in this case will be int64. Work class is an object. Objects most of the time are just strings. Like let's say here, we can't really say this is a number or a bool or anything like that. It's just a string, and strings and pandas are just objects. So in this case, everything's very clear cut. Or very clear cut, it's either an int or an object. However, sometimes, let's say you're working with data, there might be one dot because you're missing data, and that will actually convert your int64 into an object row. And when you're doing math with it, it will say, "Hey, I can't add letters," and it will just say error, just because of one element in the column. And I'll later teach you guys how to work with that and how to fix that. So always check your data types, and I'll teach you later how to actually convert them if you're working with the incorrect data types. And then okay, we're almost out of time, but then there's df.index. And so right now this is kind of a pointless index.
What does object means in data types? Are those objects, or I think I saw them as strings maybe?
Yeah. So in this case, most of the time, like 70%, 90% of the time, they're just strings. But
yeah. So strings are defined as objects here, right?
Yeah.
I mean, the data types are objects when they are strings, right?
Yeah. So essentially, for pandas, it has like its main data types would be like time, integer, float, bools.
Yeah.
But like say stuff like strings and all those other types of objects, it'll just say object. So it's another way of saying other. So essentially, it can't say, it doesn't know if this is a number or if it's a date or anything like that. It will just say object, which is just another way of really saying in layman terms other. So like it's an unknown data. So it's just object. So in this case, it's strings, but Pandas doesn't really identify strings. It just uses it as just an object. So yeah. So most of the time, like let's say in this case, these are just strings. It will just say object. So yeah, that's a good question though, since at first when you just see object, like what is that? So it's just kind of another way of, you can think of it right now as just other. And when it comes to strings, since you can't really, manipulate strings in a sense of the least and highest in strings, so it's just kind of a useless. Now I don't want to say useless, but a less useful data type for Pandas. And once we start manipulating data, you'll see what I mean. But yeah, so for now, right now, you can just think of it as other, and string is one of those other objects. So essentially, Pandas really cares about ints, floats, and like date types. And then for index, it's so essentially this index isn't very useful since we don't really have an index. It's just from 0 to 32,560. So it just goes. It'll just tell you where it starts and stops. But right now I'll show you a more useful index. And we're almost out of time, so the thing I'll show you right now are some methods or functions. So remember how I told you how with methods you can sometimes you don't need to put in an input, but you still need the parentheses. This is where that comes in. df.h.min. So essentially, I'm telling what this means is, okay, Pandas, go to the data frame. Pandas, go to the age. So it brings that column. Okay, Pandas, look at that column, which is basically one of the attributes of that object. Of that instance. Okay, Pandas, do a function to find the minimum in that string. In that column. So now we know the youngest person in this data frame is 17 years old. That easy. So essentially, okay. So look at look at this data frame. Look at this column, which is age, and find the smallest number. Now, df.h.max. Look at the largest number, right? And now .mean. So okay, I want to know what the average age is. So it's about 38 years old. See how easy that is to do. So instead of you going through columns and trying to find the min or the max, you can just .h.mean, .max. That's one of the very useful things of Pandas. And this starts getting really crazy really fast, and that'll be next lecture. But another way you can do it is like df, and then you can call the column this way. Same thing. .mean. So the mean capital gain is about, what's that, 189,778, and then the max is, I believe, 1,448,705 for capital gains, and then the sum would be this really crazy number. So you can just sum them, you can max them, you can average them. So it's like very easy with just like numbers to do manipulation like this. And just as a very, very, very quick preview of the stuff you can do with Pandas relatively easily is, let's say, .core. So I'm not sure how you guys worked with correlation matrices. Only thing you need to know is with .core, I want to know, okay, how correlated is age with word class, how correlated is word class with capital gain, blah blah blah. So I'll just do shift enter. And just to get you an idea, this is like 32,000 rows, right? Look how quick this is. Boom. So obviously age has a 100% correlation with age, but with this you can kind of know what all of the correlation coefficients are. Actually, that's not correlation, it's even correlation coefficient. But anyway, so this is your it creates another data frame just for the correlation. Now here's what I really wanted to show you with this.
So Luis, so is it just showing which are numbers? right? I mean, which are strings or objects. There is no correlation, so it's just ignoring those.
Yes, yeah, actually that's a good point. So if you notice here, we have all these different types. So these are just objects. So remember how I said objects are just other? So obviously you can't really do math on like how related is stake of to non-family. You can't really do that with math, right? So pandas is smart. Like, okay, these data types I don't I can't use, so I'll just ignore them. In other case, it won't. It'll create errors. So that's a very good point. So like it's just looking at the 3 data types that actually were, and in this case I believe N64, which means they're just integers, and it'll calculate the correlations with them. And another thing is, do you notice something different about this data frame compared to this one? What's missing from this data frame? I mean, it's not missing, but you notice how here just 0, 1, 2, 3, 4, right? And then we have the columns are nicely labeled. Here, you notice how even the rows are labeled? This is the index, right? Oh, and just as a matter of fact, notice what I did right here. Okay, df.core. So essentially, get that data frame and find the correlation matrix. So that creates another data frame for me. So, and this is just a temporary data frame. It's not. Once you if you don't assign it to anything, it'll be destroyed. But then, okay, find the index of this. So, find this data frame, which we just call df. Okay, find the correlation of it. So this is a method. And okay, from that method, you created a new actually you created a new class from that. Okay, in that new class, find this attribute. And this is how pandas works a lot. You're gonna start calling different things. Like here, you notice how there's 2 dots. This gets crazy real quickly. And if you notice, in this case, index, it's age, capital game, hours per week. And then there's, and yeah, I believe that's it for today. So, does anyone have any questions, or? Okay, so next lecture will be pivoting, and that will be very fun since you're gonna. I think that's really when you start understanding the difference between like regular data analysis of spreadsheets and using pandas. Since essentially I need to teach you how to think more of how to work with pandas than like what you typically think. Since the way you do stuff in pandas, you don't really want to ever run like iterate through data or run for loops. There's usually ways to do it automatically, so there's a problem with overthinking, and I'll get that to the next lecture, but hopefully this kind of makes sense for now. Do you guys feel like you understand more what a data frame is now with explaining classes?
I think it was good today. I think it was really informative.
Okay,
today.
cool. Yeah. Alright. Yeah, sorry, it's kind of a really weird thing to explain. It's just like, after just months of playing with it, I kind of understand it, but it's hard to explain it, so I apologize if I wasn't very clear, but...
No, it is fine.
Yeah, you explained it well.
Okay. Alright, so I think that's all for today. Thank you for coming, and I will upload this soon on YouTube.